Okay, for question number 23, we are going to graph this equation. So 23, part A, we are going to graph this equation. I will make a note first. When we have the equation in the following form, x minus h parentheses square plus y minus k parentheses square, if that is equal to some number r square. This right here, it's an equation of a circle. So I'll make a note right here. This is an equation of a circle. I'll write it right here. And the center is at h, comma k. And the radius is r. The radius of the circle is equal to r. Okay. So let's compare with this this equation, the general form of a circle, with what we have right here. So we have x minus 3. So I will write this as x minus my red 3. And then parentheses, square, plus. And then we have y plus 2. But I'm going to write that as y minus a negative 2. Oops. Parentheses, square, and here we have is equal to 4, but I'm going to write it as 2 to the second power, which is the same as 4, right? And the purpose for me to do that is so that I can match the form. So by looking at this, x minus 3, the 3 in red, we know the 3 is the h, right? And then we have y minus a negative 2. So the negative 2 is k, and we have 2 squared. So the 2 right here, the red 2 right here, is the r. So this will tell us some information. This is an equation of a circle, and we know the center is at 3, negative 2. So we match the equations. So we have 3, the k is negative 2. And the radius, as we can see, that it's not 4. It's actually, we're looking at this as 2 squared. So the radius is what's being squared, which is the red 2. Okay, so now write this down right here. Radius is equal to 2. So with this information, we can graph the equation of the circle. So let me do a nice circle right here, I hope. So the first step is to locate the center. We have 3, negative 2. So let me go right here. 1, 2, 3. And then go down. 1, 2, 3, 4. So 3, negative 2 is going to be right here. So this is the center. And then to use a radius, what I'm going to do is, actually I need to draw some more lines right here. I will start at the center, and I will go up twice. So 1, 2, and then I go to the right twice, 1, 2, and then from the center I will go down twice, 1, 2, and then from the center I will go to the left twice, 1, 2. Okay, so I'll kind of just give like 4 dots, and then I'm going to connect this with a nice circle, because we know the equation in that form it's going to be a circle. So that's part A. We have a circle with a radius is equal to 2. So that means 2 right here, and if you go like traveled, you'll get a circle, right? It's 2 distance away from the center. Then the next question, part B, asks us to find the domain and the range. So this is it for part A. We just need a graph, okay, the graph. And for part B, for the domain, so domain of the equation, domain of a function, it's all the possible x values. Okay, it's all the possible x values. So what are we looking for is, if we look at the circle, this graph is only going from here to here, right? So as we can see that if we are looking for the x values, we're only looking at all the way from here, which we start at 1, right? The x value equal to 1. So, and then the end is going to be right here. So I have 1, 2, 3, well, 1, 2, 3, 4, 5. 5 right here. So the domain is all the possible x values. So it's kind of like what's the beginning point of the x values to the end of the x value. So we have from 1 to 5. Okay, so domain we'll get is x. It's in between of x can go from anything from 1 to 5. Okay, again, domain is all the possible x value. We're looking for the starting point for the x to the end point of the x according to the graph. And then for range, we're looking for the second one for range. Similarly, the range is all the possible y value. So we're looking at the starting point, the lowest y value. Okay, so let me write down. It's all the y values. And we are looking at the lowest point of the y value, which is this point. And let's see, this is 1, 2, 3, 4. And since it's going down 4 times, this is -4. Right? This is the lowest point of the y value. And then we're going to go up to find the highest value of the y value on the graph, which is right here. And it's exactly on the x-axis. The y value right here is 0. So all the y value, all the possible y values from -4 to 0. That's it. So the range will be from -4, the lowest point of the y value, to the highest point of the y value, which is 0. Therefore, the domain is any x between 1 to 5, and the range is any y from -4 to 0. Okay? And then the last part we are looking for, we have to answer is this relationship a function or not. So let's again use the graph. So if we have a graph, in order to be a function, I'll write this down for you guys. In order for a graph to represent a function, the graph must passes the what we call the vertical line test. The vertical line test. Okay? So what that means is, okay, in this case, let me use a blue pen. So what that means is, we are going to draw vertical lines right here. So just imagine that if I draw like a vertical line right here. And as we can see that this vertical line touches my graph right here and here. This vertical line intersects with my graph twice. Okay. In this case, it fails the vertical line test because we do not want to have the same y value that produce two different y values. If the vertical line touches the graph twice, or more than once, I should say, if the graph touches the vertical line more than once, so in this case, it touches right here and right here. Since the vertical line touches the graph more than once, it fails the vertical line test. So I will say fails the vertical line test. Okay, so in that case, this relationship, this graph, does not represent a function. So the answer for part C, the answer is not a function, not a function. Because it fails the vertical line test, because the vertical line touches the graph more than once. Okay?